Welcome to Sky from Scratch. This is an educational episode and this is the first episode of the series. Today I will explain to you how a drone thinks and flies like you are a 12-year-old. So first we will clear up one misconception. This is not a drone. A drone is a misnomer. A drone is a colloquial language. This is a quadcopter. A drone is the common colloquial language of an unmanned aerial vehicle. And sometimes drones are also used to denote unmanned land vehicles also. So this is a quadcopter. Why quadcopter? Because it has 4 powertrains that generate lift. A bicopter has 2 powertrains. A helicopter has 1 powertrain. And a hexacopter has 6 powertrains. And an octocopter has 8. So this is a quadcopter. So a quadcopter is basically 4 motors spinning at precisely the right speed to keep it suspended and balanced in the air. That's it. The rest is just timing, math and sensors. So as I told you, the quadcopter creates lift by pushing air downwards. So when all the 4 motors push air downwards exactly at equal amount, the quadcopter stays level in the air and it hovers. When you want the quadcopter to go front, this is called pitch. So if it is flying forwards, what happens? So imagine the quadcopter is at level right now. All the motors are pushing air downwards at exactly equal amounts. So now you want the quadcopter to fly forwards. So how does this happen? When you want the quadcopter to fly forwards, these motors at the back spin faster than the motors in the front. So when that happens, these motors, as they spin faster, they lift up the back side. This is what it looks like from the side. The back side is lifted and these motors are creating less thrust. As they are spinning slower, these motors are creating less thrust. So the front of the quadcopter goes down. As it goes down, it doesn't go down like you crash. It just goes down a little bit. So what is happening now? The propellers, the 2 propellers at the rear, at the back side, are creating more lift. So the quadcopter is tilted and these are generating less lift. So the quadcopter is tilted like this. Now, what is the direction? What is the resultant direction of the force generated? It is not vertical. It is angular. It is this side. And because the quadcopter is tilted now, so the resultant force is angular, this side. And as the resultant force is angular, now the quadcopter flies forwards. This flying forwards, this is called pitch. Pitch is controlled by this key of the remote. This is pitching forward and this is pitching backwards. Now, if you want the quadcopter to go to the side, the principle is the same. You want it to go left, you want it to go right. So how do we do that? When we want it to go sideways to the left, what happens? These two left side propellers, these slow down, and these two right side propellers speed up. As the right side propellers speed up, what happens? The quadcopter tilts to the left, and as it tilts to the left, again the force is angular. Okay? So imagine this is the front. You want the quadcopter to go left. Okay? You want it to go left. So when you want it to go left, this propeller at the left should slow down, slower than the two right side propellers. So as these slow down, this side falls as it generates less lift, and this side pitches up as it generates more lift. So the quadcopter is tilted like this, and the resultant force vector is on this side. So it flies left, and similarly it flies right when the reverse happens. This is called roll, and roll is controlled by this key in the remote. This is roll left, this is roll right. Now I will explain to you the second dimension of rotation for an aerial vehicle, that is yaw, Y-A-W, yaw. Yaw is controlled by this key in the remote. This makes your quadcopter yaw left, and this makes your quadcopter yaw right. So what is yaw? Yaw is better explained with a small drone. So yaw means this left and right rotation. What does it look like from the top? It is this rotation. This is left yaw and this is right yaw. This is left yaw, this is right yaw. Remember, for a pure yaw, the quadcopter does not move up or move left or shift its position, or doesn't roll, doesn't pitch. It stays at the same place, but it changes its direction. So how is it achieved? Now we introduce a very interesting concept here. All of the propellers throw air, all of the four propellers throw air downwards. But it is very interesting to note that these two propellers, the front right and the rear left, these two propellers turn counterclockwise, that is to the left. Okay, and these two propellers turn clockwise, that is from to the right. So you may be asking, how is it achieved? How can these propellers move in different directions, this rotating counterclockwise and this rotating clockwise? Still, how do they throw how do they throw the air? Both downwards. This is achieved by, so look carefully, this is a clockwise propeller. A clockwise propeller is tilted to the front. See, this area is curved to the front. So when it rotates clockwise, the propeller pushes air downwards. But this is a counterclockwise propeller. See, this propeller is tilted to my side, not your side downwards. See, this propeller is tilted to your side downwards, and this propeller is tilted to my side downwards. That is how when both of these propellers rotate, this rotates counterclockwise and this rotates clockwise, but both throw air in the same direction. So how is yaw achieved? Yaw is achieved when, imagine, you want to yaw to the left. That means you want to turn counterclockwise. How do you turn counterclockwise? The clockwise rotating propellers should speed up and the counterclockwise rotating propellers should slow down, and that creates a torque that makes the drone rotate counterclockwise. So in a simpler explanation for you, you can imagine there are 4 of your friends pulling on this quadcopter. Two are pulling in the clockwise direction and 2 are pulling in counterclockwise direction. Now you want to rotate counterclockwise. So the 2 friends who pull in the counterclockwise direction, they should pull more, and the 2 friends who are pulling in the clockwise direction, they should pull less. So as the 2 friends who pull in the counterclockwise direction, they are pulling more, the drone is trying to spin in the counterclockwise direction. And when you want the drone to remain stable, the counterclockwise and the clockwise friends, all 4 of them should pull in the same amount. So we introduce the last dimension of flight, that is this throttle. So you want this quadcopter to move up or go down without moving anywhere to the sides. You just want it to move straight up or straight down. So this is how this is done. This is achieved by making all the propellers spin faster. Imagine this quadcopter is hovering stable and you want it to go up. So all these propellers should spin faster at the same rate, and this generates more lift than the lift that is required to keep it stable hovering in the air. And as it generates more lift or thrust, it goes upwards, and you want it to go down on land, all these propellers slow down by the same amount. So this is called throttle, and throttle is controlled by this joystick in the remote. This is throttle up, this is throttle down. Now we introduce the brain of the system, the brain of the quadcopter that does all the calculations for you. This is the flight controller. This is the brain of the aircraft, the flight controller. All the calculations required for the drone, for the quadcopter to stay level, go forward and not crash is controlled by this device, and this keeps you this keeps your quadcopter stable, hovering and flying in the air. This flight controller does calculations hundreds of times a second to keep your quadcopter level, hovering, flying in the air and not crash. Now I will explain to you the basic principle of a flight controller. Remember, for unmanned aerial vehicles, the flight controller does 90% of the flying. In helicopters and manned aerial vehicles, the pilot does 100% of the flying. But in these drones, these unmanned aerial vehicles, this flight controller does 90% of the flying. Now I will explain to you the role of the flight controller, the basic principle of the flight controller with a smaller drone, with a smaller quadcopter, so that it is easy for you to understand. Imagine you want your quadcopter to stay stable and hovering over here. Now this flight controller has a lot of sensors, lots of sensors like in your mobile phone. It always checks the orientations. It checks the orientations in all the three axes, the X, Y and Z axis. Okay, so as to keep the quadcopter flying stably, and it checks them and makes small corrections hundreds of times a second. So the flight controllers, gyroscopes, the magnetometers, these are very important components and their precision is crucial to a stable flight. So imagine you want this quadcopter to stay right here, suspended over here, and imagine there is this wind which has tilted the quadcopter a little bit to the side. So there is this gyroscope, this accelerometer that says that the quadcopter has tilted to the back. So do the correction. As soon as it has tilted to the back, the flight controller speeds up these motors, these back motors, so that the quadcopter is level again. Now imagine there is this gust of wind coming here, and this quadcopter is pushed to the right. So what happens? Whenever it is pushed a little bit to the right, the accelerometer sends this data to the flight controller, and the flight controller speeds up these motors, and the quadcopter stays level again. And thus these corrections, these checking the accelerometer data, this gyroscope data and the magnetometer data, this happens hundreds of times a second, and these propellers are sped up and slowed down hundreds of times a second in order to keep your quadcopter, your drone, hovering stably. This also happens when you have put unequal weights. Imagine this part of the quadcopter is heavy. You don't have to perfectly balance a quadcopter in order to be able to fly. So this is the job of the flight controller, to keep it stable, of course within limits of the motors. Put a load, an unequal load on this arm, and when it tries to lift off, the flight controller senses that this part is heavy, and that is why it is tilting. So this motor spins a lot faster than these three motors in order to create lift so that it remains stable. Now imagine there is a gust of wind from the downward side, or there is some turbulence, and this is pushing your quadcopter upwards, but you want it to remain stable over here. So there is this barometer inside your flight controller. This barometer senses a minute variation in air pressure as it is pushed upward. So it corrects by slowing down all the propellers so that it maintains a stable altitude. Now there is this wind that has made the quadcopter yaw. Now this is checked by the magnetometer. This magnetometer is actually a compass, and the magnetometer says, no, the north is over here. So these two propellers, like I have shown, slow down, and this creates a torque, and the orientation is maintained again. Imagine balancing this stick on your hand. You can see that in order to keep the stick stable, my hand keeps adjusting very fast, and I am getting visual feedback. This is what happens. I am getting visual feedback from my eye. So what happens is that the flight controller gets feedback from the different accelerometers and adjusts to keep the drone stable and hovering in the air. Let me give you an analogy. If you love anatomy, the brain does not directly speak to the muscle in order to let the muscle adjust and keep the stick stable. Brain or the flight controller speaks to the muscle, the motors, through the nervous system, the ESC. Most interesting thing is that the flight controllers do not control the motors directly in a large quadcopter like this. The flight controllers talk to the motors through ESC or electronic speed controllers. These electronic speed controllers are like gearboxes. They monitor the RPM and report back to the flight controller. They monitor the RPM of each of the motors and report back to the flight controller, and they adjust voltage and frequency so that the motors are kept rotating at the particular RPM, perfectly particular RPM that the flight controller wants it to be. So the motors, the ESC or the electronic speed controllers or gearboxes, and the flight controller, these are the most important parts of a quadcopter to make it stable and reliable. And now we move on to the accessories. This is the GPS. This is an optional component in a quadcopter. These GPS are like your phone's GPS. They determine the location, the altitude. But these GPS are much accurate than your phone's GPS. Your phone's GPS has accuracy of some meter. These GPS called constellation GPS, these have accuracy up to a few centimeters. So you might have seen videos of drones landing on someone's hand. These GPSs are so accurate, and these GPSs help the drone to track its position, to maintain hovering in a stable area, stable position, not to tilt or sway. And also this GPS helps the drone do autonomous missions. If you want the drone to go somewhere, take pictures and come back, this GPS helps to track the location. This GPS also helps the drone to return home in the RTL mode. These GPS are the eyes of your quadcopter. It helps to track the location, the altitude, everything with centimeter precision. Now there is one important selection that you make while trying to build your quadcopter or your drone. That is the fuselage or the frame. The selection is very important. I will tell you why I chose this S500 frame. I chose this S500 frame because it has a carrying capacity, it has a load capacity of over 2 kg, and it has this upsweep arms, which is very important for a stable landing. And these arms are reinforced by carbon fiber rods, and these are carbon fiber landing gears. Carbon fiber is very strong yet very light, so I chose this frame because it is also very affordable. This is your transmitter remote. This is what controls your quadcopter according to your inputs. This is what sends the input to the quadcopter. This is the receiver. This receives the inputs from your remote control. These are the antennas of the receiver. See, I will tell you in the next video why I chose this antenna, these two antennas to be oriented in 90 degree perpendicularly. Okay. So this is the battery. This is the powerhouse of your quadcopter. So you need to make a very good selection of battery weight and power. This is the telemetry module. The telemetry module is a wireless communication module that reports back to you all the flight data. If anything wrong is happening, if you have all the GPS set, if there is something wrong with any of the components, it reports back its location, it reports back the ground speed, it reports back the air speed, and it also reports the location, the altitude and everything. This telemetry reports back to the ground, not directly, reports back to your mobile or your computer, not directly, but via a ground station. This is the ground station that I built. It connects to my laptop or phone either via wired connection or via a wireless Bluetooth, Wi-Fi or Bluetooth connection. And this has a range of around 10 kilometers. Later in the video series, I will show you how I built this telemetry module and the ground station. This is the camera. I am using a Hawkeye Thumb 4K camera because this Hawkeye Thumb 4K has a very good feature, very interesting feature, that it can record 4K videos with gyro flow stabilization, and it can record these high quality videos in an SD card, and also it has a video out. It has video out. This video out is connected to the VTX or the video transmitter. This video transmitter, this is the video transmitter, and this is the video transmitter antenna. This is a pagoda type antenna. This video transmitter transmits what the Hawkeye Thumb 4K mounted in the front of the drone is seeing. Like, like you have your, you are standing here, but you have your eyes on the drone, like you are really flying. Okay, so if you put on your goggles, this is the first person view you can see, or you can see the feed on your computer in your mobile as well. So this is the receiver for the video transmitter. When matched with a similar polarized antenna, you can see that I am using a pagoda antenna like the transmitter. With a 1.6 watt transmitter, I can get around 10 kilometers of range, line of sight. So you can connect this USB to your phone or to your laptop. You can use any web camera app to see the video feed, a live video feed from the drone. These video transmitters use the analog protocol. This analog protocol is like those olden day TV, like we had in our childhood. What is interesting about is that these analog transmitters are susceptible to interference, but they have very low latency. Like you are almost getting a live feed. It is just delayed by a few milliseconds. So because of this low latency, this control is almost real time. So what you see is almost what is happening at that moment, right where the drone is.
So this is it for today's educational episode. If you feel you have derived any value from this episode, please consider sending this video to your friends or family members or someone who might benefit from this video, because it's word of mouth referrals like this that will help to make the channel grow, and I want to reach as many people as possible so as to provide free high quality content to everyone. Before we move on to the building process of our drone, in the next video I will answer one big question. Why build an FPV drone like this for yourself when you can just buy a ready-made drone and get on flying with it? So why build an FPV drone? I will discuss all the advantages and also the disadvantages of building an FPV drone for yourself. So see you in the next video. Till then, take care and please subscribe to my channel to get notified about the next video.